Hello everyone. Today we are going to talk about something that might sound a little technical, design patterns in Selenium Java automation. But I promise I'll explain it in a fun and easy way. We will use a real world example that everyone can understand, running a pizza shop. By the end of this video, you will not only understand what these design patterns are, but also when and how to use them in your own test automation projects. Let's start Let's start with a simple question. What are design patterns? Imagine you own a pizza shop. Every day, customers place orders. You have someone taking the order, someone making the pizza, and someone delivering it. Each of them have a clear role and the process is organized. You don't change the recipe every time someone asks for a margarita pizza. You have a recipe card. You don't buy a new oven every time. You just use the same one efficiently. That entire setup is a kind of design pattern. It's not random, it's structured. Similarly, in test automation, especially when using Selenium with Java, we follow design patterns to keep our code clean, organized, and reusable. Without design patterns, your automation framework can honestly become messy, repetitive, and hard to maintain as your application grows. Let's go over the three most commonly used design patterns in Selenium: the page object model, the factory pattern, and the singleton pattern. We will start with the page object model or POM. Let's say you're testing a login page. Without POM, your test might directly access the web elements like this. You find a username field by its ID and type in the username. Then you do the same for the password and click the login button. It works. But here's the problem. If the login page changes tomorrow, maybe the ID of a field changes. You will have to update every single test where you have written this code. That's where POM comes into picture. Instead of writing the same code over and over again in your test files, you create a separate Java class for each page, just like having a recipe card for each pizza. All the elements and actions related to that page go into this class. So the login page class might store the username field, password field, login button, and a method to perform login. Then in actual test, you just say create a new login page object and call its login method with the credential. That's it. The test is much cleaner now, and if the login page changes, you only need to change and update it in one place, that is in login page class. This is a huge time saver and makes your code easier to maintain. Let's look at this Java code snippet for a login page. For example, this login page has username, password, and a button to click to log into the web page. So this is a class named login page, which has the page elements defined using the locators like ID and CSS locators. And we have a constructor class method defined to initialize or creating the login page object. And then we have a bunch of page objects, page object methods, which is entering the username, entering the password with the given password, and then clicking on the login button. We also have combined all of these page methods into an action called login, wherein we provide the username, password, and then click on the button of login. So once that is done, let's take a look at the actual test to perform the test of login. So in here we have two tests. One is to test the valid login and another is to test the invalid login. So both of these firstly create the login page using the new keyword, and then you perform the login operation using the action method. And then you can add your assertion logics here according to your test case scenario. Similarly, for invalid test case, we are reusing the same method of login to perform it, and this time we would capture the error message using the same login page method and assert the error. So this is a simple example of how the POM works with one single page object class related to login. But similar to this, we can create a number of pages related to our application under test and reuse all of those combined actions and operations from these page object classes in all the test cases. So this enables reusability, maintainability, and clean code. Okay, coming to the next one, the factory pattern. Think about the pizza machine in your shop. You tell the machine, give me a margarita, and it gives you exactly that. You don't care how it's made, you just get it. In automation, the factory pattern does something similar. Instead of manually creating a new object for each page class in every test, you create a factory class. This class has static methods that return the page object you need. So now, instead of writing a new login page every time, you just call page factory dot get login page using the driver. This makes your test scripts cleaner and it centralizes object creation logic, which is really helpful as your test suite grows. You don't repeat yourself, and changes in how page objects are created can be made in one place. Finally, let's see some examples related to the page factory. This is a code snippet related to page factory. So this is where you initialize your driver, and then you also have a method which takes an input of page name. The page name can be login page, dashboard page, profile page, setting page, etc. And it can go on and on. So for this example, we have taken these as an example. And based on the page name, the respective page object class is returned. So this way, there is one place called page factory where you are creating all the objects. This is an alternate approach of using enum. So instead of having the string name in the string page name in the string format, we are using enum called page type and passing that as our switch. So it could be login, dashboard, profile, settings, etc. And it would return the same thing. And if none of them match, then we would return a exception message called illegal argument exception for this. Let's take the example of its usage. So this is a test class, factory usage test. Let's name it as factory usage test, which extends the base test. And in here, we are performing a setup operation, which will be triggered before the methods, all the test methods. And we are creating a new object of page factory and initialize the driver. So in this test, if you can see, we have a string-based factory wherein we are passing the page name as string and getting the login page object, and then using this login page object to perform the operations like login. Similarly, this is the approach with which we have created the enums. And this is an example of how the enums are created for the page type. Finally, let's talk about Singleton Pattern. Back in the pizza shop, imagine each chef buys their own oven. That's expensive, unnecessary, and inefficient. Instead, everyone shares a single oven. That's exactly what the singleton pattern is in Selenium. You don't want every test creating a new browser instance unless absolutely necessary. It consumes memory and can cause stability issues. With singleton, you can create a class that manages a single instance of the WebDriver. When you create a when you ask for a driver, it checks if one already exists. If it does, it creates if it returns that one. If not, it creates one and returns it. So, across your entire test suite, there's only one WebDriver instance unless you explicitly reset or close it. This pattern is extremely useful in large frameworks where you need more control over how and when browsers are opened and closed. It keeps your framework efficient and prevents common issues like stale driver sessions or memory overuse. Now that we have gone through the three major patterns, let's see some examples related to singleton. So let's talk about the driver manager. Here we have a driver manager who is basically managing the driver related actions and operations. So this is a private constructor to prevent instantiation of this driver manager. So that's one of the uniqueness of the singleton class, where you do not have a public constructor, and then you have a static method to get the actual driver. So now in here, if the driver is null, only then it will be initialized. If not, the driver which is already created in the previous session would be returned. So if we have to take a look at the initialized driver, this is based on the browser type that we choose. So if we choose a browser type as Firefox or Safari, so that would be chosen. If not, by default, Chrome would be used as a browser type. So once you have identified your browser type, you have to initialize your WebDriver, either a Chrome, Firefox, Edge, Safari, etc. And you can create as many as cases you want based on the driver requirements that you have. And then once that is done, we always have to make sure that we are maximizing the window of the browser. And we can also optionally set our implicit wait of 10 seconds for every operation that happens, or we could exclude this and use explicit wait, which we can talk about at a later point in time if that's required. And then another key operation related to the driver is quitting the driver. So if you want to quit the session, browser session altogether and close all the browsers, we choose this option to quit and exit everything related to the test and come out of it. So this is a test usage of this particular singleton pattern in our test. So let's see. So in the test setup, we are looking at the base test, which is basically a parent test class, which will be used by all of our test classes, like a parent class and subclass relation. So in the base test, we are initializing or getting our singleton driver instance using this approach, wherein we are accessing our static method called getDriver, which is in the driver manager, and providing the Chrome as our browser type, and then we are fetching our driver. Once we get the driver, we perform rest of the operations like getting to the navigating to the URL, etc. So this is our actual test, which is login test, which extends the base test In here, we already have our driver initialized with singleton pattern. We just have to use it through a driver named driver. So now that we have gone through all the three major patterns, page object model, factory pattern, and singleton pattern, let's talk about when to use them. Use POM for any web application with multiple pages. It is basically the foundation of a good test framework. Use the factory pattern if you find yourself repeating the object creation logic across your tests. And definitely use singleton if you need to reuse the same browser instance across multiple tests, or if you are managing the driver lifecycle within your framework. Together, these patterns make your code more scalable, readable, and maintainable. Think of them as the recipe system, pizza system, pizza machine, and shared oven of your test automation kitchen. To wrap up, POM helps organize code per web page. Factory gives you a clean way to get page objects. Singleton ensures you are using a single web driver efficiently. They work best when combined in a mature modular framework. Thanks for watching. If this helped clarify design patterns in Selenium, give this video a like, share it with your team, and subscribe for more QA and automation content made simple. If you have questions or want a deeper dive into any of these patterns, leave a comment below and I'll be happy to cover it in another video. Thank you.